Prime numbers are the atoms of the mathematical universe. A prime number like 2, 3, 5, or 7 can only be divided by 1 and itself. They are the building blocks of all other numbers. The Riemann hypothesis is a deep mathematical puzzle about these prime numbers. It tries to understand how prime numbers are sprinkled throughout all numbers. Think of it like looking for seashells on a vast beach. The Riemann hypothesis tries to predict where you might find the next seashell, even if the tide is constantly shifting the sand. Imagine listening to an orchestra. You hear a beautiful melody, but hidden within the music are individual notes played by different instruments. Prime numbers are like those individual notes. The Riemann hypothesis is like the conductor's score, revealing the hidden patterns and harmonies within the seemingly random distribution of prime numbers. Mathematicians have discovered that the distribution of prime numbers is not random. It follows a certain rhythm, a kind of music that can be described by a mathematical function called the Riemann zeta function. The Riemann hypothesis is like a master key. If we can prove it's true, it will unlock many secrets in mathematics. It would be a major breakthrough, like discovering a new continent or a new fundamental force of nature. For example, it would help us understand how encryption works, which is crucial for keeping our online information secure. It could also lead to new discoveries in physics and computer science. The Riemann hypothesis is a testament to the power of human curiosity. It reminds us that there are still mysteries out there waiting to be solved. Proving the Riemann hypothesis is one of the biggest challenges in mathematics. It's like trying to climb Mount Everest. Many mathematicians have tried, but so far, no one has succeeded. The problem is that the Riemann hypothesis deals with infinite numbers, and our tools for understanding infinity are still limited. It's like trying to study the entire ocean by just looking at a single drop of water. Section 5. The landscape of numbers. Imagine, if you will, a vast, uncharted landscape. Mountains rise in the distance, valleys stretch out below, and rivers carve their way through the terrain. This is the world of numbers. The Riemann hypothesis is like a mapmaker's compass, guiding mathematicians as they explore this complex terrain. It helps them navigate the intricate relationships between prime numbers and understand the underlying structure of this numerical world. Section 6. Zeros, the keys to the kingdom. The Riemann zeta function is like a treasure map, and the zeros of the function are like the X marks that pinpoint the location of buried treasure. The Riemann hypothesis makes a specific prediction about where these zeros are located. It says that all the non-trivial zeros lie on a specific line in the complex plane, called the critical line. If we can prove that all the zeros are indeed on this critical line, we will have unlocked the secrets of the Riemann hypothesis. Section 7. Random matrices, a surprising connection. One surprising approach to solving the Riemann hypothesis comes from an unexpected area, the study of random matrices. Matrices are arrays of numbers that are used in many areas of mathematics. Random matrices are matrices whose entries are chosen randomly from a specific distribution. It turns out that there are deep connections between the statistical properties of random matrices and the distribution of the zeros of the Riemann zeta function. This unexpected link has provided new insights and tools for tackling the Riemann hypothesis. Section 8. The future of the hypothesis, a universe of possibilities. The future of the Riemann hypothesis is full of possibilities. New approaches and ideas are constantly being explored, and the development of powerful computers offers new avenues for investigation. Perhaps the solution will come from a completely unexpected direction, from a young mathematician with a fresh perspective, or from a breakthrough in a seemingly unrelated field. Section 9. The enduring allure of the unknown. The Riemann hypothesis is a powerful reminder of the beauty and mystery that lie at the heart of mathematics. It is a testament to the power of human curiosity and our relentless pursuit of knowledge. Whether or not it is solved in our lifetime, the Riemann hypothesis will continue to inspire generations of mathematicians and fuel the fires of mathematical inquiry for years to come.